Hi everyone, welcome to this new lecture of fluid mechanics. In this lecture, we'll discuss a new topic regarding the gradual closure of valves, which is the part of water hammer in pipes. In our last video lecture, already we have discussed the concept of water hammer in pipes, and the gradual closure of valves is one of the condition in water hammer in pipes. So in our last lecture already we have discussed regarding this water hammer in pipes, and there we can see similar kind of diagram we have considered to understand the concept of water hammer in pipes. And as I told you that gradual closure of valves is one of the condition in water hammer in pipes. So let me give a brief introduction about this picture. So here this is the tank is there. This is the tank what we have considered, and the one pipe is connected to this tank, that is AB pipe is there. So in the tank here water is filled. This is the surface level of water, and which is placed, we can say, which is the height of or head of H is there from the inlet of the pipe. Okay, so this is the head of the water surface level from this inlet of the pipe, or you can say the center line of this pipe, and the AB which is there, which is taken with a length of L, and the velocity of fluid which is flowing through the AB, that is V, and remaining like diameter is there. Okay, and end of the pipe, at the end of the pipe a valve is connected to this. This is the valve is there. This valve is connected to this end of the pipe to control the fluid flow which is flowing through the pipe. Okay, and the first condition is gradual closure of valves. So when you close the valve gradually, then what is the head value? What is the head of pressure will be there? And when you close suddenly, that is one more condition there that we'll discuss. But for this condition, let identify what is the head pressure head will be there. So for this is about this diagram, as I told you, this is the tank or chamber you can consider here, and this is the surface level of the water, and this is the inlet part, this is the outlet part, and this is the valve is connected. So let me consider a few terminology which is used for this diagram. Okay, so first one, the area of the pipe A. This is the pipe is there, as I told you, the pipe AB pipe is there, and for the AB pipe, first one, let's consider A is the area of the pipe, and as I told you, the L equal to the length of the pipe, L equal to the total length of the pipe AB, and as I told you that similarly V, the velocity of the fluid flow, through the pipe AB, and next is P can be considered. P, this is intensity of pressure. This is intensity of pressure of wave which is produced. How the wave is produced? When you close the valve, suddenly a shocking will be created, that is water hammer. When you close the valve even gradually, slowly, still there will be a wave will be formed in the reverse direction like this. So the P will be considered the intensity of pressure when the wave is produced. And T, we need to consider one more terminology, T. This is the time in second when this valve is required to close. That means how much time you are taking to close the valve. So these are some terminologies are there which is going to be used to identify the pressure head for this. Now, first of all, when the water is flowing from this tank to this this pipe, first let identify what is the mass of water in the pipe AB. So first point, let me write the mass of water in pipe. The mass of water in pipe AB equal to, we can write this is what is the volume of the pipe and what is the density of the pipe. So that one we can write rho into volume. So the volume in terms of, we can write this is area into length. So this one we can write rho A L. rho AL. Now, when the valve is closed, this is the valve is there. Okay, when you starting close this valve, like means now it is fully closed, it is visible. Now suppose this valve is there, and you are slowly you are trying to close the valve in this pipe. Now the time taken to close this valve, okay, from initial position to final, like means when you started closing this one, now see it is suppose initial position is here only, the valve is there. Now at this, when it is open, let's think that the valve is open fully, so the velocity which is flowing through this pipe, some velocity is there, like V, as I told you here, when valve is open. Now when valve is closed, slowly it is fully closed, the velocity is going to be 0. So from velocity V to velocity 0, what is the time taken? What is the time taken to close this one? To find out this, we need to consider a new terminology, that is a retardation of water. Retardation of water. That means to make the velocity 0, what was the time taken here? So for that, we need to consider like how to find out this retardation of water. That is change in velocity. Initially, what was the velocity was there? So you can write here del V by time taken. So del V equal to nothing but what is the initial velocity, what is the final velocity. Initial velocity is 0, V was there, and final velocity is 0, and what is the time taken, T. So this one we can write V by T. Similarly, we can find out the retardation of force. The retardation force, what is there? Retardation force you can say also a resisting force, okay, to make this velocity 0. What is the retardation force is there? So that is nothing but mass into what are the retardation we found in the previous terminology, this one. So okay, so mass into retardation, that means what is the mass of the fluid which we got here, that is rho AL, or you can say rho V. So rho into A into L, and what is the retardation is there, that is V by T. So here you can give a equation, this one as an equation 1. Okay, this is retardation force. Now as I told you, the pressure intensity P, when it is intensity of pressure is formed, now when we are closing the valve fully and there is a wave formation will be there, that is the intensity of pressure. So if the intensity of pressure wave produced when it is closed, then the force due to this pressure wave, which is created, so that one we can write, that is P into area. This is the force due to the pressure wave. Okay, force due to the pressure wave equal to intensity of pressure into area. So this one we can give equation 2. I try to understand how this force came here. Here retardation force, another one is force due to the wave which formed here. The intensity of pressure P, because we know that P pressure equal to force by area, so the force which is created here, that one we can write P into area. Now if you equate this to equation 1 and 2, now equate equation 1 and 2, what we can write here? We can write rho AL into V by T, equation 1, equal to, here we can write P into area. So here again we can write, this is P equal to area you can cancel it, area you can cancel it. So here you can write rho LV by T. Okay, this one we can give equation 3. Okay, now actually we need to find out the head of pressure. So head of pressure equal to, we can write H equal to P by rho G. We know that this is the formula, the pressure head equal to P by rho G. Now we got the equation here, P in terms of this value rho LV by T. Just put this value here. So we can write rho LV divided by this one we can write rho gt. So rho gt, okay, let it write first, then we'll cancel it. So finally what we'll get here, this rho can be cancelled and we can write LV by T. This is another equation, we can mark it here. So this is the head of pressure. Now head of pressure means what? At this position, what is the pressure head? Okay, so pressure head equal to the intensity of pressure with respect to the specific weight, we can say W, that is rho g. So we have two conditions will be there here. The valve closure, see, when the valve is closing to be gradual, when you're saying this valve is closing gradually, in that condition, because it depends upon the time also, because we are closing the valve slowly, then that depends upon the time period. What is the time taken here? So for that, what we can read, the valve is closure is said gradually. Condition is if the time period, if the T is greater than 2L by C. Now here you can see T, as I already told you, time in second, and C is the velocity of pressure of wave. Now C is the velocity of pressure of wave. This is one new value. This is C value. That will be given, or we need to identify. Now second one, this is about gradually disclosing. Now if the valve closure, this valve closure is suddenly you are closing this one. If you are closing suddenly the valve, then in that condition, when it can be happen, or when it is, now when T is less than this 2L by C. Again same thing, C need to be considered velocity of pressure wave here also, same thing. Okay, so these are the terminologies are there which are used in this equation, and these are the two conditions, and this is the formula what we got, the pressure head, okay, of the water. So I hope you understand this concept. When you're closing the valve gradually, what will the pressure head value will be there, and this is one of the condition in the water hammer in pipes. So if you're having any kind of doubt, query regarding this, you can give a comment on the comment box. Thank you all.